Hi, it's Mr. Anderson, and this is AP Physics Essentials, video 18. It's on thermal conductivity, which is a property of matter that either allows it to transfer heat readily from a hot to a cold object or doesn't. And so the materials that I use every morning when I make coffee, it's important that they have varying amounts of thermal conductivity. So the electric kettle that I use, the element that heats up the water is metallic because we want to transfer as much of that heat to the water as we can. But the handle that I use to pour it is plastic, and that's because it has low thermal conductivity. We don't want to transfer a lot of that heat to my hand. Likewise, the press that I press the water through the grounds is plastic, so I'm not burning my hand. And so the ability of matter to transfer heat from a hot to a cold object is called its thermal conductivity. And it's based on the structure of that material, both at the atomic and molecular level. And so if we have something like a metal that's a good conductor of electricity, it's probably also a very good conductor of heat. And the reason why is there are these delocalized electrons, and it allows that heat to move through the material. Now, nonmetals can also pass heat, and they do that not using these delocalized electrons, but using phonons, which are waves in the lattice itself. And so you should be able to calculate thermal conductivity of different materials in an AP Physics class. And so what is thermal conductivity? Well, we measure it in watts per meter Kelvin, but what it's really showing us is how heat can readily be transferred from a hot object to a cold object. And so if we have these two objects in isolation, there's not going to be heat flow between them. But if I move this metal in the middle, there's going to be the transfer of this kinetic energy from the hot object to the cold object. And the ability of that material to transfer that heat is called its thermal conductivity. And metals are very good at conducting that heat. And that's because they share their electrons in this delocalized cloud, and so the electrons are actually transferring the heat. If we were to take something like wood, it's going to have low thermal conductivity. If I were to put it between the hot and the cold objects, heat is still going to be transferred from the hot object to the cold object. But since there aren't these free electrons, it's not going to be transferred as readily. How is it moving then? Well, this whole wood is a lattice, and you get these waves inside the lattice called phonons that are actually transferring that heat. Now, you can experience this right now. So if you're standing or sitting at a table like I am, I'm going to put my hand on something that's a non-metal, so that's going to be the surface of the table. And then I'm going to put my other hand on the bottom of my chair, which is metal. And so it's going to be a really good conductor. And the question I ask you is, which one is colder? Which one's warmer? And so when I feel those both, I feel like the table is warmer than the chair. But they're both exactly the same temperature. I wasn't touching them, so they're both at room temperature. So why does the metal feel colder than the wood? It's because it has better thermal conductivity. And so if we were to look at a few objects, copper, which is a good conductor of electricity, is also a good conductor of heat. And so we would say it has a value of 401 watts per meter Kelvin. If we were to look at something like brick, it's going to have lower thermal conductivity. Styrofoam, would have really low, and so it's a fractional amount. And then a vacuum would have zero thermal conductivity. We shouldn't be able to move heat through a vacuum. Now, in an AP Physics lab, you should be able to measure thermal conductivity. And this is kind of a pretty ingenious setup on how you could do that. So what we have over here on the right is a steam generator. So it's generating steam, and that's going to move over here. So that's going to be our heat source. And it's just going to start to build up in the steam chamber. The steam chamber is enclosed on the top, and then some of the water that condenses can leak down out the bottom. And so what you do is you put some kind of material on the surface of that. So we have a plate here, in this case it's metal, and then we put some ice on the top. That ice has a consistent size, and it also, since it's frozen, is going to have a consistent temperature. You turn on the steam chamber, and what's going to happen is it's going to melt that ice. It's collected right here, and then that water can be measured. So we could look at the time and the amount of water that's being converted from a solid to a liquid. So we could measure the thermal conductivity from the steam chamber to the ice. We could then try a different object, maybe some wood, and we would see that it's going to have lower thermal conductivity. And then we could try some kind of an insulating plate as well, and we could see that that's going to even be lower amount of thermal conductivity. So it's a really quick way to measure how quickly heat is being transferred between these objects. And so did you learn to design an experiment to analyze data that will show you thermal conductivity? This is a great example, and I hope that was helpful.